Hello, today we are looking at 10.5 in our notes packets, which is going to cover surface area of pyramids and cones. So first let's talk about what a pyramid is. A pyramid is a solid with one base. Unlike our prisms and our cylinders from the other day that had a top and a bottom, pyramids are only going to have one base, and they are going to have triangular lateral faces. So they're going to have triangular shaped sides. And they're going to join at a vertex. Then we know a vertex is a sharp point. A pyramid has a height which drops into the center of the pyramid, and a slant height, and we have the slant height, you're going to see that as the cursive letter L, which lies on each face and is perpendicular to the base. The pyramids we will work with will be regular pyramids. Remember, we talked about regular, that means that all sides are going to be the same. So if we look down at our little pyramid right here, we have a base, one base right there, and it's going to be a regular shape, so in this case it's going to be a square. The L is the slant height. That is the height of the triangular face. You also have a height of the pyramid, which goes from the vertex down to the center of the base, which is going to also be perpendicular with that base. So we have two different heights, which can get confusing. So just make sure that you keep the slant height and the height of the pyramid separate. The big difference between the pyramids and cones opposed to the prisms and cylinders is prisms and cylinders had a constant width the whole way up. It was the same shape from top to bottom. When we look at the cone, it's wider on the bottom and it comes to a point on the top. So it's not a constant shape the whole way. So we've got new formulas. Our lateral area is going to be 1/2 the perimeter times the slant height. And that is going to be the perimeter of the base. And then our total area, just like before, is that lateral area, but instead of having two bases, because remember before we had a top and a bottom, now we only have one base, so we only add one base in for that total area. So let's go ahead and get started. When we look at number 1, we want the perimeter of the base. Remember we said that this shape is regular, so this is 6, 6, 6, and 6. So we have 4 sides of 6, giving us 24 feet for our perimeter of our base. Our base is a square, or you could say a rhombus, depending on how you want to look at it, but it's a square, and that's going to be base times height. And it's regular, so our base and our height are 6 and 6. 6 times 6 is going to give us 36 feet squared. Our lateral area brings us to our first new piece, 1/2 perimeter times slant height. We have the perimeter from step 1, which is going to be 24. We don't have the slant height given to us. So first part is figuring out what the slant height is. The slant height is that height, that's really bad, of the lateral face, which is a triangular side. So we are trying to find that height right there. We need to use Pythagorean Theorem to find that out. So we're going to create a triangle. We were given the height of the actual pyramid, which is 4 feet. This whole thing on the bottom, the base, is 6 feet wide. So this is going to be halfway, only because it's a regular shape. So this means that this piece is going to be a 3. We can use our Pythagorean Theorem. 3 squared plus 4 squared is equal to our slant height squared. So we've got 9 plus 16. Our slant height squared is 25. We square root that. And our slant height is going to be 5. Again, all we did is we created a triangle inside of our pyramid using the height of the pyramid, cutting the base in half to get the bottom, and then solving for the hypotenuse, which is the slant height. So we just found that that slant height is going to be 5. 1/2 times 24 is 12. 12 times 5 is going to give us 60 feet squared. Then our total area, the lateral area are 4 triangular faces. And then for the total area, all we do is take that lateral area and add the base onto that. So the lateral area from the previous step of 60 plus 1 base, which we found the base was 36, gives us 96 feet squared. So the same process, just slightly different formula here. Let's go on to number 2. Here we still have a pyramid. Our base this time is a triangle. It's still a regular shape though. So since that's 40, this is 40, and this is also going to be 40. So I have 3 sides of 40, giving me my perimeter of 120 feet. The base, our formula for the area of our base, because it's a triangle, is 1/2 base times height. We have a regular or an equilateral triangle, so I have to find the height of that triangle. So I'm going to drop the altitude, which I didn't drop it very well, but you know when you drop it, because it's equilateral, this is 60, this is 60, you bisected that angle to get a 30-30. This side is going to be split, that 40 is going to become 2 sides of 20. Across from 30 is your S, across from 60 is your S root 3, and across from 90 is the 2S. So we have, again, this is going to be 20, this is 40, the height is S root 3, which is going to be 20 root 3. So when we go back, we have 1/2 the base of that triangle. I dropped my altitude this way, so that base is going to be 40 times the height of the triangle, which is going to be 20 root 3. We still want an exact answer, so we take half of 40, which is 20. 20 times 20 is going to give us 400 root 3 feet squared as the area of our base. We also could have used our special formula from the last unit, L squared root 3 all over 4. Our side length there is 40. 40 squared root 3 all over 4 will give you that exact same answer of 400 root 3. It's up to you which equation you would like to use. So our lateral area, 1/2 perimeter times slant height. We have 1/2 the perimeter from step 1, which is 120. This time we were given the slant height. It's pointing to the height of your lateral face, that triangular side, which is 21. 1/2 of 120 times 21 is going to give us 1,260 feet squared. Total area, the only thing I have left to do is to find or add on to the base from that lateral area. Lateral area plus 1 base. So we get 1,260 plus 400 root 3. When I look at those two pieces, they are not like terms. One has a square root and one does not, so I keep them as 2 separate pieces. And there's my final answer. Alright, for our next pyramid problem, it's going to look very similar to our first one, because when we look at our base, we have a rectangular base again. Regular, so all sides are 10. So if I want the perimeter, I have 4 sides of 10, giving me a perimeter of 40 feet. The base is a square, a rhombus, however you want to look at it, and that's base times height, so 10 times 10, giving us 100 feet squared. Lateral area, 1/2 perimeter times slant height. So this is where it's going to change a little bit. Remember, the slant height that we're looking for is the height of our lateral face, the triangular side. So we need to find this L. You want to really pay attention to the diagram that you're given. Some of you may have just said, okay, it's 13. That 13, though, is pointing to the corner of your pyramid. That's not the slant height. The slant height is the height of that triangular face, which is slightly different because in number 1, I gave you the height of the pyramid. So I gave you a different piece of the puzzle. You can still go ahead and find the slant height the same way. This side right here has a length of 10, but because it's regular, it's going to be bisected into 5 and 5. So to find our slant height, it's your 5 squared plus slant height squared is equal to the hypotenuse of 13 squared. So this is the triangle that I'm doing my Pythagorean theorem with. So we get 25 is equal to L squared, plus L squared is equal to 169. We move the 25 over, and we find that our slant height is going to be equal to 12. So we go ahead and fill that in. 1/2 the perimeter from step 1 times the slant height that we just found of 12. 1/2 of 40 is 20. 20 times 12 is going to give us 240. Oops, I've been using the wrong units the whole time. Our diagram is in yards. Alright, and then our last one, total area, we take that lateral area and we add on that one base that we have, 240 plus our base area of 100. So our total area of that pyramid is 340 yards squared. Alright, go ahead and flip over to the next page. For our first quiz, we had prisms and cylinders. Now we have pyramids and cones. A cone is a solid whose base is a circle, similar to the cylinder, and whose sides taper up to a vertex. So the difference was our cylinder was that same width the whole way up. Instead of being that same width the whole way up, it's going to taper off and to meet at a point that is a vertex. A cone has a slant height, has a height which drops to the center of the cone. So if we look at our cone right there, this is going to be the height of our cone, and it also has a slant height, which again is that cursive L. And the slant height for a cone is much easier. It's just going to be the lateral face. So because unlike our pyramid, which had flat sides, our cone is going to be the same the whole way around. All of these are the same height coming from the vertex down. So any slant height on that outside is the same. Good news is that our lateral area formula and our total area formula are the exact same as we had for our pyramids. So let's go ahead and get started. We want the perimeter of our base. Our perimeter of a circle is their circumference, which is 2 times pi times r. So 2 times pi times, I need my radius. I am not given my radius or my diameter, but I am given that this is 10, this is 6, so I can create a triangle to use Pythagorean Theorem. 6 squared plus r squared is equal to the hypotenuse of 10 squared. We've got 36 and 100. R squared is equal to 64, square root. So our radius in this case is going to be equal to 8. We fill that in, giving us 16 pi inches for our perimeter. The area of a circle is pi r squared. So we've got pi times, we just found the radius was 8 squared, giving us 64 pi inches squared. Moving on to our lateral area, 1/2 the perimeter, which we found in step 1, which is 16 pi, times our slant height. When we look at our diagram, 10 is our slant height. It's the distance, it's that curve on the outside of that cone. So it's given to us here as 10. So 1/2 times 16 is 8. 8 times 10 gives us 80 pi inches squared. Total area, just like the pyramid, we don't have two bases. We don't have a top and a bottom. We just have one base. So we take that lateral area of 80 pi. We add our one base area, which we found in step 2, 64 pi. 80 plus 64 gives us 144 pi inches squared. So hopefully you are getting the hang of this. Let's move on to number 5. We want to find the lateral area. Remember, when I don't request all the information, only do the information that you need. So for lateral area, I need perimeter and slant height. For our perimeter, we need 2 times pi times r. 2 times pi times, when I look at this, 16 is your diameter, so our radius is going to be 8, giving us 16 pi as the perimeter. Slant height, we are lucky, is given to us as 17. So we have 1/2 perimeter of 16 pi times slant height of 17, giving us a lateral area of 136 pi millimeters squared. Alright, we are on our last problem for our notes today. Total area. I asked for the big one, which means we need lateral area plus 1 base. For lateral area, I need 1/2 perimeter times slant height. For base, this is a circle, so I need pi r squared. Let's go ahead and start with our perimeter. We have perimeter as 2 times pi times our radius, which is 9, times our slant height. We are not given the slant height. This corner piece right here, this is our slant height. We're given the whole height of the cone. We're given the radius, so I can do Pythagorean Theorem of 9 squared plus 12 squared is equal to our slant height squared. So we've got 81 plus 144. So we are going to have 225. So we square root that, and our slant height is going to be 15. So 1/2 times 18, or 1/2 times 2 is 1 times 9 is going to be 9 pi. 9 pi times 15 is going to give us a lateral area of 135 pi. Then we have the area of our circle. Pi times our radius squared is going to give us 81 pi. So we add those two pieces together, 135 pi plus 81 pi. Those are like terms, they both have pi's, so the total area is 216 pi feet squared. Alright, we are done with our notes video. Go ahead and turn to the next page, and in your groups, you need to work on that group work on the next page. You have 4 problems to work on. When you are done working in your group, go ahead and go to the front and check your answers that are on the teacher's desk. Alright, have a good day.